All right, hello you guys. So we are going to talk about map projections and scale of analysis in this lecture. Okay, so get ready to take some notes. And the good news is that you can pause right anytime you want and take your time with it. Okay, the PowerPoint's also on Schoology, so always take your time. Okay, so we'll start off with map projections here. Okay, so this is kind of continuing right the conversation with the introduction to maps. Okay. So map projections are going to be a little bit different than the thematic maps that we've been talking about. Okay, so as all of you might know by now, right? Maps are selective in information, right? It's kind of impossible to fit every feature or piece of data into a single map. Okay, and so map makers have to decide how much of Earth they want to show, how to show it, and what to show it. Okay, and so one way that map makers, geographers do this is through map projections. Okay, now the thing with map projections is, they're taking this three-dimensional object that is Earth and trying to make it two-dimensional. Okay, and so that creates some issues because when you're trying to make a curved surface right into a flat surface, right, what does that do? Well, it's going to inevitably, right, distort spatial relationships in shape, area, distance, direction. Okay, so a curved surface, right, cannot be represented on a flat surface without some distortion. Okay, and so therefore, right, every map projection, right, every 2D map that we see, okay, is going to have a distortion. Okay, so again, just looking at this, this little diagram here, right, of the grid or the globe into a grid, right, you'll notice that looking at the globe, right, it's not all perfect squares like we're used to seeing on a map. Okay, so depending on the type of projection, right, there'll be a certain distortion. Okay, so all map projections are going to have one of these four distortions. Okay, and the acronym that geographers use is SAD, right, to kind of memorize, right, the four distortions that map projections will have one of, right? So map projections, right, will either distort one or all of these, right? Shape, area, distance, and direction. Okay, so it's important to understand that every projection has distortion and that at least one part of SAD, right, is going to be preserved while the others, right, might be distorted. Okay, so all maps, right, are going to make some compromise. Okay, and there are different techniques. Okay, so let's look at a couple of map projections. Okay, the first one here is going to be the Mercator projection. Okay, and so the Mercator projection is probably the most famous map projection, right? I mean, I have it in my classroom, right? Other teachers probably also have it. Social studies teachers, right, are going to have the Mercator projection. So it's kind of in the shape of a rectangle. And so, the original purpose, right, of the Mercator projection back in the late 1600s was for navigation. Okay, and so that's one of the strengths of this projection, right? Is that directions are accurate, right? It was actually the Mercator projection is and was used, right, for as a marine navigation tool. Okay, because if you look at the grid there, the lines of latitude and longitude, right, kind of create 90-degree angles on the map. And so with straight lines, it's kind of easy to travel between places, right? Say you wanted to get from Portugal to Brazil. Okay, you could easily calculate that. Okay, so directions are accurate. The shape of the countries, right, are accurate. Like I said, the lines of latitude and longitude are at right angles. Okay, but the distortion with the Mercator projection is that the lines of the land masses, sorry, right, are kind of the size, right, of these countries and continents are a little wrong, right? Actually, not a little wrong, they're very wrong. Okay, so land masses near the poles appear larger. I mean, if you look at Greenland, right, it's somehow larger than Africa, right? And that's not the case. Hopefully that doesn't surprise you. Europe as a whole seems to be as large as South America, right? Even though that's not the case. Okay, so if you look at the Mercator projection, right, I mean, Greenland, right, would look bigger than Africa, but the actual size, right, actual representation is as you see there on the right on this map here. Okay, and Africa in general, right, is pretty large. Okay, and you can see how many countries actually fit in there. Okay, so another criticism of the Mercator projection is the fact that, right, so many of the, more developed countries, right, United States, right? Countries in Europe, right, are larger than, some of the less developed countries. Okay. And some would say that, because they're larger, right, we kind of have unconscious bias, right, that somehow the countries in the United States and Europe are better. Okay. Second projection here is the Peters projection. Okay. And so the purpose of the Peters projection is to, for spatial distributions to be related to area. Okay. And so the strengths of the Peter projection here, right, is the fact that the sizes of the continents and countries are more accurate, right? Way more than the Mercator. The only problem here is that the shapes aren't accurate, right? If you look at Africa and South America, right, and they look kind of elongated, right? They kind of look stretched out. And so the shapes of those are wrong, okay? And if you put over the Peters projection, the Mercator projection, right, totally different. Somehow Europe is way more northern than the Mercator would suggest. Okay. Third projection here we're going to look at is the conic projection. Okay, so the general use of this, in mid-latitude countries. Okay, strengths, right? The lines of longitude converge, okay, as they should. All right, so these lines here, these white lines converging here in the North Pole. Right, the lines of latitude are curved, right? I mean, that's how it is, right? If we're looking at the globe. Okay, shapes are close to reality. The only distortion here is that direction is not constant, okay? And I think that's easy to see when you're looking at this projection, okay? Fourth projection here is the Good-Hamilton projection, okay? So purpose, right, to just better use, right, spatial distribution, okay? And I mean, it minimizes distortion. The only problem here is that it's kind of hard to present information with this, okay? So even though area and shape might be preserved, right, it's kind of hard to actually use this map to show data or anything like that, okay? And it struggles with direction, okay, mainly because the oceans here are kind of interrupted. Fifth here is the Robinson projection, okay? So, I mean, strengths of this, right? Sizes, closer to accurate. The ocean sizes look more accurate. There doesn't seem to be any major distortions, okay? I mean, it's an oval shape, so it isn't a rectangle, so at least it's trying to, preserve, the fact that the Earth is a globe, okay? But there are distortions, of course, right? Antarctica looks very large. Greenland looks flattened, right, north to south, okay? And the polar areas, right, are very distorted, okay? So what's interesting about the Robinson projection is actually the fact that, all of SAD, right, are distorted, right? The size, area, distance, and direction, right, are all distorted. Okay. And this came out very blurry, but here's another projection for you just to look at, right? The fuller projection, okay? So anyways, here's a table that you can look at, right? Just to look at the advantages and limitations of some of the map projections. There's also a table like this in your textbook, all right? So take a look at that, all right? The goal here isn't to memorize, projections, okay? But to understand that map projections, try preserving, either shape, area, distance, or direction. But ultimately, all map projections, right, are going to distort some aspect of Earth, okay? And a little fun thing you can click on here, right? A website to the true size of countries, right? If you wanted to take a look at that. Okay, it's pretty fun, so just take a look at that, right? Cool, so scales of analysis. Okay, so we looked at map projections, okay, trying to make sense of that. All right, and now we're gonna look at scales of analysis. Okay, so we're gonna continue to look at maps here, all right? So scales of analysis, kind of the objective here, the learning objective with scales of analysis is that you should be able to define, right, what they are, okay, why they're used by geographers, and ultimately explain what scales of analysis reveal at different levels, okay, and we'll get to it in a second. So if you look at this map here, right, choropleth map, right, Robinson projection, okay, but we're gonna add yet another layer, right, and try to understand the scales of analysis with this one. Okay, so when we talk about scales of analysis, we are not talking about this scale, right? We're not talking about cartographic scale, okay? Something that you've all learned in elementary and middle school, right? So ignore this, okay? This is not what we're talking about. What we are talking about is geographic scale and scales of analysis. So let's kind of break it down, all right? So geographic scale, different than scales of analysis, but still important, all right? So when we talk about geographic scale, right, we're talking about the amount of territory that a map is representing, okay? It could be global, national, regional, or local, sometimes called subnational. So let's take a look at some examples, right, so that you know what I'm talking about here. Again, and the amount of territory that the map is representing, okay? So geographic scale, okay, if we're talking about, you know, a global scale, right? I mean, we'd be looking at a map of the world. So this one, for instance, right? We're looking at, again, right, a map of the world here, right? So it's a global scale map, this one, okay? Here are very concrete examples for you, right? Again, if we're looking at a map of the world, right, that's a global scale. If we're looking at a map of a specific country, right, that's a national scale, okay? Map of a specific country. If we're looking at a regional scale, a regional map, right, that'd be a map of a specific area of the world, okay? And so with this one, we're looking at Latin America, right? If we're looking at a local scale, right, we're looking at a map of a state, city, a county, okay? And here we are, right, a map of, you know, the immediate Portland area. That would be a local scale, okay? So that's what we're referring to when we talk about geographic scale. So different scale means, you know, different variations in data and different interpretations of data, okay? So you could think of scale as kind of like a hierarchy, right? They're not disconnected, right? But they are interconnected. Okay, so sometimes the local, national, or global scales might seem disconnected because, you know, we think of them different, you know, politically and, you know, with our boundaries, okay? But while we can see those distinctions, the reality is that, you know, it's much less spatially fragmented, okay? They're all connected in some way, all right? So here's another type of scale to consider, right? Before we look at scales of analysis, all right? You could consider how zoomed in or zoomed out, right, on map or images, all right? So map scale highlights the visibility of available features on a map, right? So if we're looking at a, you know, at a world map, right, a map of the world, that would be a small scale map, believe it or not. And the reason why is because we're zoomed out, right? We're not looking at many details, okay? So we have to use generalities. If we're looking at a map, say of the city of Atlanta here, right, and you know it's different, you know, highways, right? That would be a large scale map because we're zoomed in, okay, and so we have greater detail, all right. So map scale, right, in this case, right, highlights the visibility of features on a map, okay. So important to know, okay. Here's another example for you, all right. This would be a large scale map and then a small scale map, right? Large scale because we're zoomed in, small scale because we're zoomed out. All right. Other examples for you, right? This map of Mexico here would be a small scale, and this map of Mexico here would be a large scale, right? Cool. So now that we're familiar with this, right? The you know how zoomed in or zoomed out we are, right? Now that we're familiar with geographic scale, right? Whether a map is global, regional, national, local. Let's add another layer to this, okay? We're going to talk about scales of analysis. Okay, so scales of analysis, right, can be tricky at first, but you know, once you understand, right, its definition, right, it makes sense. Okay, when we're talking about scales of analysis, we're talking about the observation of data on a global, national, regional, or local scale. All right. In other words, how the data is chunked or organized. All right. So another way to put it, right, is the level of analysis at which the data is aggregated, right? Again, how the data is organized, combined, right? So when we're talking about scale, like this one here, and when we're talking about scales of analysis, okay, we're talking about different concepts, okay? So if you ever get confused with scales of analysis, always ask yourself this question: how is the data aggregated? How is the data chunked? How is it organized? Okay. So again, we're going to look at the four main scales here: global, regional, national, and local. All right. So Scales of analysis here. All right. First, we're looking at a global scale of analysis. Now, I'll just say that, we're not going to look at a global scale of analysis often in this class, so you could kind of brush it aside if you wanted to, okay? But this is a type of scale analysis in which data is organized at the global level, okay? So you'll notice that there are no political boundaries, okay? You can't really make out the countries. You can only make out, the continents and the world as a whole, all right? It's really not that useful, this global scale of analysis, and it's almost impossible to use, again, because it's a small scale map, because we're zoomed out, okay? A more frequent scale of analysis that we'll see in this class is a national scale of analysis. Okay, so this is a type of scale analysis in which data is aggregated at the national level, okay? In other words, the data is organized, right, by country, all right? Sometimes, right, by state. Okay, so this means that the map is displaying data for one or more countries. Okay, and notice here how political boundaries, right, are depicted on the map, right? So boundaries, countries, borders, that's all important, all right? And this is where it could get tricky, all right? The scale is global on this map, but the scale of analysis is national, okay, because the data is organized by country, okay? So here's another map that you could look at, all right, even though it came out very blurry for some reason. All right, again, national scale of analysis, right, because the data is organized by country, by nation. All right, next here we have regional scale of analysis. Okay, so this is a type of scale analysis in which data is aggregated at the regional level. Okay, so this means that, the map image is displaying data within specific continents, specific world or regions. Okay, so you'll notice how there are regional boundary lines. In other words, boundaries that are a little fuzzy, okay, but there are no national boundary lines. Okay, so we're not seeing, you know, countries' borders, right, and boundaries, okay. So we'll talk more about regions later, but a region, right, any area that can be grouped together based on common characteristics, okay. So um, a regional scale of analysis, right? Super effective for comparing regions, say for life expectancy, okay? So this would be a regional scale of analysis, okay? Even though we can't see, the countries here, right? I mean, the data isn't organized by countries, okay? It's organized by regions, all right, by specific characteristics, okay? So we'll see that Northern Africa, the Middle East, right, Western Asia is, main religion would be Islam, right? We're looking at North and South America, right? We can see that this region of the world is Christian, right? So regional scale of analysis here. Okay, here's another map, all right, again with religion showing, right, a regional scale of analysis, okay? So again, even though we can see the borders of countries, right, and the boundaries, the data isn't organized by country, it's organized by region, okay? All right, and so the fourth type of scale of analysis here is going to be the local scale of analysis, okay? A type of scale of analysis in which data is aggregated at the local level. So this means that the map, the image is displaying data within specific subregions of a country. If we were looking at the United States, right, in this case, would it be by states, right? Sometimes it could be by counties, right? Sometimes it could be by zip codes, okay? So it's very effective to determine local issues, right? Like where you should build hospitals, right? If you, depending on the piece of data you're given, okay? So again, notice how there are subnational boundary lines here within the US. So the map is at a national scale, but the scale of analysis is local, right? Because the data is aggregated, organized at the local level. Okay, here's another map here with a local scale of analysis, okay? So looking at the leading church bodies. So this is from a while ago, right? The year 2000. All right. Here's a map of of 2016 of the 2016 election, right? We can see the counties and the various counties in the United States, and whether they voted Republican or Democrat, right? So again, this is a local scale of analysis, right? Because data is organized by counties, right, which fits in with this here, right, subregions of a country. Okay, nice, and yet another one for you. Okay, so recapping here, right, analyzing scale and scale of analysis. Again, so when you analyze maps, always ask yourself two important questions, right? What is the geographic scale of the map? Right? What is the scale of analysis? All right. So if you can answer those two questions, right, as we move through the course and through the year, right, you'll have a better chance of analyzing and comparing maps. Okay. So a true building block of the course, right? Understanding scales of analysis. Okay. So again, just be wary of the geographic scale and scale of analysis. So, the geographic scale of this map is global, okay, but the scale of analysis is national, okay, because the data is organized by country. All right. So one last quick note here with scales of analysis, okay. Variations in data, okay. It's important to understand not only what are the different scales of analysis, but why geographers even, learn it in the first place. And it's because data at one level compared to another will tell you a different story. Okay. And this can lead to people drawing conclusions about what scale they're using. So let's see a few examples, right, so that we can make sense of this. Okay. So here's a map of the United States. Okay. So local scale of analysis here. Okay. And this particular map is looking at deaths from cancer. Okay. So if we're looking at this map of the United States, right, the local level, okay, we can see that, you know, um, these two states right in the South, right, Mississippi and Louisiana, seem to have the highest rates of cancer, right, along with Kentucky. Okay, Maryland here, right, doesn't look like it gets as much deaths. Okay, but right, at first glance, we might say, oh, Maryland, right, we could disregard them. I mean, they don't have that many deaths from cancer, all right? Um, but when we zoom in, right, into the state of Maryland, okay, we'll see the different counties of the state and see that, wait a minute, okay, maybe there are more deaths, right, from cancer than we realized at first glance, okay? And if we really zoomed into a particular county, right, we could see what specific areas, right, what zip codes, right, feature the most deaths, right, from cancer, okay? And so again, it's going back to data at one level versus another, right? Telling a different story. Okay. I mean, just looking at the map of the United States as a whole, right? This choropleth map. I mean, Maryland doesn't look like it gets many deaths, but again, when we zoom in, right, into counties, then into specific towns, right, we'll see a major difference there. And then we can start asking important questions like, why is that? All right. So 2016 presidential election map, sorry, right? I mean, if we take a look at, let's take a look at Tennessee for this one. All right, if we looked at this map, right, we would see that, oh, first glance, Tennessee, right, most of the state seems to have voted Republican. Okay, but as geographers, we always have to zoom in and ask more questions. Is that the case? All right. And so if we looked at it at a county level, we could see that, oh, it looks like that even though most of Tennessee may have voted Republican, there are some blue spots, all right? And if we zoomed in, right, we could see that some major cities like Memphis and Jackson in Tennessee, right, actually voted mainly Democrat, okay? Especially Memphis there, all right? So again, first glance here at this um, local scale of analysis, right? We would see Tennessee, but the more we zoom in, the more local we get, right? We'll see that that's not the case. And again, then we can start asking, oh, so why is Memphis, right, different than the rest of Tennessee, right? Is it the people there, maybe? The age of people there? Okay, is it the fact that it's more urban than the rest of Tennessee? Okay. Another map here looking at Michigan's population. Okay, if we looked at the map on the right, again, a local scale of analysis, right? we would see, you know, that it seems that Michigan, right, has a very high population density, right? But if we zoomed in, right, if we looked at specific counties, right, we could actually see which counties and which cities might have a higher population density than other parts of Michigan, right? Because of course, right, people are not spread out evenly in Michigan, all right? It's very different. Okay, here's another map in your textbook, just looking at life expectancy at birth. Okay, you can take a look at that one in your book, but it's a good one to look at, so I'd look at it. Okay, and lastly, looking at scales of analysis, not just in maps, but in tables as well. Okay, so information at different scales. So table 1 here is looking at median household income for selected places, right? In 2018, right? I mean, we can see it at a national level, we can see it at a local level, and an even more local level, right? The county level. All right, and at first glance, we'd be like, oh, you know, California, right? It seems that maybe everybody, right, there makes about $71,000 in general, all right, as the median income, all right. But if we looked at specific counties in California, right, if we zoomed in, so to speak, right, we would see different income levels depending on the county. And again, that's where we can start asking questions like, why is that? All right, why is it that San Francisco County is making way more than in Butte County, for example? All right. So that's the lecture, you guys. If you have any questions, let me know. But definitely go back, right, if you missed anything, and take your time on this, all right? Skills of analysis is super important, all right, as is just understanding map projections, okay? So lots of good stuff. I feel like we're getting into the good stuff now. All right, so anyways, let me know if you have any questions.